the Director General and the Directorate have decided to place a task force against COVID-19. To leverage on our competencies and on our large network of relations with several institutes in the world, the aim of this task force is to help society, to help doctors, to offer our competencies with their guidance, to see where we can deploy at the best our technologies. Of course, the CERN employees and the CERN users, all our collaborators, have been a fantastic source of these ideas and proposals.
Dans ce groupe, on a des ateliers de traitement de surface et le laboratoire de chimie, et donc on a quand même pas mal de stocks de produits chimiques. Et maintenant, nous avons fabriqué plus de 1000 litres de ce gel hydroalcoolique qui va partir à destination de la France.
The several tasks that have been proposed, the main ones of which we are concentrating now are the ventilator, because this is in high demand everywhere for intensive care units.
The kinds of pressure regulation that we do in the lab routinely when we're developing systems for our experiments, it's very similar to what you need in order to build and control the elements of a ventilator. A very important aspect of this design is that it's based around components which should be cheap and also should be readily available. It's increasingly a problem at the moment in the construction of ventilators that some of the standard components are simply not available on the market anymore. We want to make something rapid, which could nonetheless really comply with the most strict hospital standards. Jan, who is our lead designer, had this idea of a buffer which is alternately filled and emptied. And in this way we can control the pressure in a way which is safe for the patient.
So there is the computer screen that shows the cycles. So it's now roughly 1 second of inhale and 1 second of exhale. The air enters here through a regulator at about 2 bar. It's regulated down to 600 millibar. Here you have a valve that will allow the air to enter the buffer while this one is closed. When the fill is complete, this one closes, and then the inhale cycle can start. That means we open this valve and the air will go through this tube, which is a medical equipment, into what is called a test lung. And then you see that this test lung is filled with about half a liter of air on a regular interval.
We are also active in the field of producing with our 3D printing washable masks and also face shields.
We are mostly focused on designing and constructing experimental physics detectors. The idea today is to respond quickly to the requests which are coming from, for example, from the NSC hospital, but other people are requesting, even at supermarkets and so on. We can easily probably produce more than 100 masks per day, and we have basically raw material to produce up to 500 of them today. We hope that meanwhile we will get new supplies and we will have a certified process throughout the task force.
Then the other important initiative is our support in terms of computing and also in terms of data analysis. Of course, this with the guidance of the experts for our computing power that we usually have there for our data analysis, but for other specific goals like finding a specific therapy and vaccine. And all this in the consultation with experts from the WHO and from doctors that we have been starting to have contact with.